We're getting started. This is just a 30-minute class, a younger student class. So we've got 30 minutes for our second class. I believe it's our second class in Modern Arithmetic 2. In the first class, I explained that Modern Arithmetic 2 is intended for students in third or fourth grade, I believe, third and fourth grade. Modern Arithmetic 2 is intended for students who are 9, 10, 11 years old, or anyone who's older who would just like to go back and learn arithmetic. But Modern Arithmetic 2 is different from Modern Arithmetic 1. In Modern Arithmetic 1, we said the focus of that course is studying objects, right? Counting objects, adding with counters, subtracting, multiplying, dividing, using sensible objects. It's simple baby arithmetic. All right? And the reason why Arithmetic 1 doesn't ask the students to think a lot is because children come into the age of reason around 8 years old, right? So when children are younger than 8 years old, they can't learn in the same way that they can learn as they get older. So little children have to be able to learn using their senses, but as they come to the age of reason, when they get older, they can start to use their intellect. They can start to use their mind. They can start to reason and use the imagination, understanding. So Arithmetic 1 is for young children, and it doesn't require them to use their intellect. But in Arithmetic 2, in Modern Arithmetic 2, we study the same content that we studied in Arithmetic 1, but we study it in a different way. And I said that Modern Arithmetic 2, let's take a minute and get our notes ready. Make sure at the top of your page you have your name and the date. Make sure you have the name of the class, which is Modern Arithmetic 2. And this is lesson number 2. So in Modern Arithmetic 2, if you look at your textbook, you'll see that the title of this textbook is Intellectual. Copy this down. Intellectual Arithmetic. This is not classical arithmetic. This is simple, modern, school arithmetic. Practical, simple arithmetic. But this second course is called Intellectual Arithmetic. And the reason why it's called Intellectual Arithmetic is we're going to start learning arithmetic in a different way. We're going to start learning arithmetic using our mind and our imagination more than our senses. You understand that? Okay? That's what it means to grow up. To grow up means you start to use your intellect, you use your understanding, you use your reason rather than just your senses. When you're a little baby, or when you see another child who's a baby and they want something, they're hungry, they're thirsty, what do? They just go crazy, right? They have no reason. They don't understand that if they just wait 20 minutes, it will be lunchtime. They can't reason like that. So when they want something, a baby just starts crying and screaming, right? It's not reasonable. They can't understand that lunchtime is coming. All they know is that they feel hungry. They have senses, but they have no intellect. They're not reasonable. And as you get older, what's supposed to happen is you're supposed to stop acting like a baby throwing tantrums every time you want something. You're supposed to become more reasonable. And when your body tells you something, when your senses tell you something, your understanding, your intellect is supposed to keep your senses and your body and your desires in control. Your intellect tells you, calm down. It's almost lunchtime. Right? So you become more intellectual. And arithmetic, the study of mathematics, is one part of our school studies that helps us to learn how to become more intellectual. All right? We don't need to sit around like cavemen, unga bunga, counting beans in order to understand numbers. We can just think about numbers. We can think about quantities. And that's what we're going to work on in arithmetic 2. In our first class, we talked about the first 3 lessons in this book. And we said the first 3 lessons in this book are for students who didn't study arithmetic 1, right? The first 3 lessons in this book are for students who didn't study arithmetic 1. So if you're a student who didn't study arithmetic 1, you should work on lessons 1 through 3 until you learn all of that information, and then begin lesson 4. Lesson 4 is really where this book begins, this course begins. So in this lesson, in this second lesson, we're actually going to be studying lesson 4. Okay? Our second class on lesson 4. Now in the last class, the last thing we talked about was all of the addition facts. Right? There's a whole chart with all of the addition facts, adding from 1 up to 12. You should know all of those addition facts by memory. In lesson 4, what we're going to do is we're going to start thinking about addition. We're going to start solving addition problems with our intellect. This is intellectual arithmetic, okay? So what I'd like you to do is listen. You don't have to look at the computer. You don't have to read this. Just listen to the questions that I ask. We have a bunch of questions. And what I want you to do is simply think about these problems and solve them in your minds. And you're going to give me an answer in a certain way. So the first question, think with me, ready? Think with me. You don't have to write this, just think. 3 and 8 are how many? 3 and 8 are how many? 11. Okay? That's a good baby answer. You memorize, and when someone asks a question, you just say the answer. But what you should say is 3 and 8 are 11. Right? And my next question to you is going to be why? Why? Why are 3 and 8 11? Why did you say 3 and 8 are 11? And the answer is 3 and 8 are 11 because we memorized 3 plus 8 equals 11. You got that? We're taking our first step in intellectual arithmetic. Notice we didn't say $3 and $8 are how many dollars. You notice that? We didn't use concrete numbers. We didn't say Mary has 3 pennies and Amanda has 4 pennies. How many pennies do they? We didn't use any objects, right? We just asked about the numbers themselves. 3 and 8 are how many? 3 and 8 are 11. Why? Because 3 plus 8 equals 11. No objects, right? Nothing in your hand, nothing on your desk. All of your calculation is in your intellect. That's intellectual arithmetic. Understand that? No objects. 6 and 9 are how many? 6 and 9 are how many? How should you say it?
6 and 9 are 15.
6 and 9 are 15. Why?
Because 6 plus 9 are 15.
Because 6 plus 9 equals 15. All right? So we're still using our memory work, but we're learning how to answer arithmetic questions without any objects. All right? Because it doesn't matter what the objects are. 6 and 9 always equals 15. Right? It doesn't matter if it's dollars, or if it's pounds, or if it's beans. 6 and 9 will always make 15. The object or the unit doesn't matter. We can just think of the numbers without any object. We don't have to have beans in our hand or pennies on the table. We can just think of the numbers. This is intellectual arithmetic. 4 and 4 are how many? That's not how you answer the question. 4 and 4 are 8. Why?
Because 4 plus 4 equals 8.
Right. We're not looking to see if you can say the answer. We know that you can say the answer. If you studied Arithmetic 1, we know you know the answer. What we're focused on here is how you think about the question and how you answer the question. Right? A solution is not the answer. A solution is an explanation of how you find the answer. The solution to a problem is not the answer. So just yelling out the answer is not how you solve a problem. The solution is an explanation of how you solve the problem. I can use a calculator if all I want to find is the answer. I can just type in the numbers. I can say, okay, 4 plus 4, enter, and it will tell me the answer. But that's not a solution. A solution is an explanation for how we answer a question. Okay? We're starting to learn how to do that, how to solve problems. So when I ask you a question, what we're focusing on here, even though this is very easy, we're focusing on how to answer the question in the right way. All right? Because this is going to get more complicated as we go on through the lessons. So just because this is easy, don't be arrogant and say, oh, this is so easy. It's not going to be easy in a few more lessons. So let's practice and learn how to do this the right way. 4 and 11 are how many? You can just immediately start answering. If I say 4 and 11 are how many, you can just start. 4 and 11 are 15. Why? Because 4 plus 11 equals 15. So when I answer the question why, I give the solution, an explanation of how we find the answer. That's the solution. The calculator can tell me the answer. That's not what I'm looking for. That's not what we're trying to learn in arithmetic. We're not just trying to figure out how to get the right answer. That's why children can cheat in school, in math classes, because all the teachers ask them for is to find the right answer. What we really need in arithmetic is to learn how to find the solution. And the solution is an explanation of how to find the answer. Do you understand that? You understand the difference between finding the answer and finding the solution? The solution is an explanation of how to find the right answer. And again, these are very easy questions. The questions aren't going to be easy. All right? Let's keep going. Number 3 asks, 5 and 9 are how many? 5 and 9 are how many?
5 and 9 are 14.
Right. 5 and 9 are 14. Why? How do you know that? How do you know that 5 and 9 are 14? Because
5 plus 9 equals 14.
because 5 plus 9 equals 14. So we use our memory work as the reason for the answer, right? We explain the solution. How do I know the answer is 14? Because in our memory work, we learned that 5 plus 9 equals 14. Pretty simple, okay? Now, in lesson 4, it goes on, it gives us many, many problems to solve. There's 29 different sets of problems, and each one of those numbers has 3 or 4 different questions. So there's lots and lots of questions to answer. Now, I'd like to ask you a little more difficult question, all right? When you do these exercises for your lesson, you're going to have to answer all of these questions for the assignment. But I'd like to ask you some more difficult ones, and you might want to write them down, okay? Just to help you remember the numbers, okay? I'd like you to tell me how many are 29 and 8? And remember, this is intellectual arithmetic. How many are 29 and 8? And remember, if you get the right answer, you still have to explain the solution. So how are you going to explain the solution? That's what you need to think about. You can't just tell me the right answer. You have to explain the solution. How do you know how to find the right answer? The question was, how many are 29 and 8? How are you going to find the solution? Okay? Anybody want to try it? How many are 29 and 8?
29 and 8 are 27.
Are how many?
27.
No. 29 and 8 are not 27. Just think about that. What did you do wrong? 29 plus 8 more are 27? That makes no sense. You didn't even think about the question. Do I need to give you counters? Do I need to give you a pile of beans on your desk so that you can count them and figure out the answer? You told me that 29 and 8 more make 27, which is less than 29. How can 29 and 8 make 27? That's baby math. You need me to give you some beans? Huh? You want some beans on your desk? Or are you going to think about it? Think. How many are 29 and 8? How many? 37. So what? That's the answer. That's not the solution. But you have to think about it. You can't just say because 29 and 8 are 37, because we didn't learn 29 and 8. How are you going to explain the solution? How are you going to explain the solution? That's the hard part. 29 and 8 are 37. Why? You didn't memorize 29 plus 8. So how are you going to give the solution? You have to think about how to solve this problem. Let me give you an idea. We learned about numbering, right? We learned about units and tens, right? 29 is the same as 2 tens and 9 units. 29 and 8 is equal to 8 units. 29 and 8 are 37 because 9 units and 8 units are 17 units, or 110 and 7 units. 110 and 2 tens makes 3 tens. 3 tens and 7 units are 37. So there, I explained the solution using only my memory work. Do you understand that? Instead of thinking of 29, why don't you explain the solution for me? Explain it. You don't know the explanation? Because you're not even paying attention. That's the difference between baby math, babies with counters on their desks, and intellectual arithmetic. You can't learn arithmetic if you're not going to learn to think. You can get through arithmetic 1 with counters like a baby, pushing things around on your desk, but in intellectual arithmetic, you have to learn how to think. You have to make yourself pay attention. You're in control of your thoughts. It's like a man driving a horse or a man driving a car. It's true, the car can go wherever it wants. It can go all over the place. But what's the driver for in the car? The driver's in the car to control the car, right? If there's a car that drives all over the place, the driver's not doing his job. Your mind will wander all over the place. That's the difference from being a baby and growing up. For intellectual arithmetic, you have to get control of your thoughts. You have to make your thoughts obey reason. You have to control your thoughts. You're the driver of that car. If you don't pay attention and don't think, you're still a baby. You need counters so you can look at something and hold something and think about it. But that's not intellectual arithmetic. So it's a good example of the difference between primary arithmetic, arithmetic 1, and arithmetic 2, right? The solution to these problems, what we saw, the first couple of questions, you are arrogant because you think, oh, 7 and 8, that's so easy. This is like baby work. And I told you it's going to get more difficult. It's going to get more difficult quickly. And by the time we're down halfway through the questions in this lesson, you're already not able to explain the solutions. Right? You have to learn to think and reason. You have to learn how to use what you know. You have to learn how to use what you know to answer questions that you don't know. You understand that idea? You have to use what you know. What do you know so far? All you know in this book so far are the addition facts. And you have to think to yourself, how can I use my knowledge of the addition facts to answer this question? That's intellectual arithmetic. We're not going to put 29 beans on your desk and then add 8 more. That's not intellectual arithmetic. You have to learn to use what you know, simple addition facts. You have to learn to use what you know to solve a problem and answer a question that you don't know. This is why you're taught about tens and units. You can take a number like 29 and realize that it's not 29 units, it's also 2 tens and 9 units. You can add 9 units and 8 units to make 17 units. That's addition facts, memory work. And you can look at the number 17 and say 17 is 1 10 and 7 units. And you can add 2 tens from 29 and 1 10 from 17 to get 3 tens and 7 units, and 3 tens and 7 units makes 37. And that's the solution. Do you understand that? For this lesson, the assignment that you're going to have to complete for your assessment is going to require that you write out the solutions to all these questions. Not just say the answer like a baby, but explain the solution. And so you're going to have to work through them for this assessment for lesson 4 in Arithmetic 2, okay? So I'm warning you, arithmetic gets difficult fast. So don't be deceived by the easy questions at the beginning. This is your second arithmetic course, and it's going to get more difficult quickly. All right? You've got to control your thoughts and learn to use what you know to solve questions that you don't know. And so that's what you're going to be tested on, even in this lesson 4 in Arithmetic 2. So what I'd like you to do is take a few minutes, write a summary in your notes of what we learned about and talked about in this lesson, and that'll be all for our second class in Modern Arithmetic 2.